Hey, Sam here. So today we're going to be following on from our last UX lecture where we looked at design systems, and we're going to be looking at the practical day-to-day side of a design system, which is its component library. Just like a builder makes sure to tend to their tools, as front-enders, we often have to create our tools for doing our jobs. And that means creating the shared UI components that we reuse throughout an application, creating a component library. So as a front ender, it's really important to understand, have an understanding of component libraries. Today we're going to be looking at three things about component libraries. First, we're going to be looking at how designers understand and see component libraries, because that filters through to how we see them as engineers. Secondly, we're going to have a bit of a look at different ways we can implement a component library, looking at some open source ones. And then third, we're going to look at a tool that can help us implement a component library, and I'll be doing a bit of a live coding demo. So exciting. First, onto what is a component library. So components, I suppose, components are little bits of user interface that we can use to put together to make an application. Examples of components would be like an alert, so like a little thingo that's got some text and like is in a bubble and it's like a little warning or error or something. A button is a component, a slider, a badge, a card. There's endless numbers of components that you interact with on your daily life. So often we don't want to re-implement a button from scratch every single time we're building a new page and application. So we use a component library that lets us define what a button looks like in one place and then reuse that throughout the application. Component libraries, is really important to note, isn't something that just developers think about. The idea of reusing and creating consistency is really important to user interface design. A great user interface isn't one that makes the user think. You don't want the user guessing at every screen, is this a button or is this not? You want to have a sense of consistency throughout the user interface. So we see that designers often have component libraries as well. For a designer, a component library is a collection of graphical elements that they can reuse. So by making a mock-up of a new application at Canva, instead of having to redesign what a button looks like, I can just grab a button from my library, plonk it in the app and start using it. And ditto for front-enders. So obviously for front-enders, they're not graphical elements, they are pieces of code. But if I want a button, I can import from UI-based button. I have a React component and I can use that so I don't have to think about styling button. So that's at a very high level of what a component library is. But I think the first question is, how do designers understand component libraries? So I think in order to really understand, so we talked about design systems last week, why they want a component library, to create a sense of consistency. But we need to take a step back to understand how user interface designers are creating their designs and see how components figure into that process. So, this button. So if we have a look at popular user interface design applications, we find out about things like Sketch, Figma, or Adobe's XD application. And it's really interesting to think about, these applications might not be familiar to you. So I know a lot of people are familiar with applications like Photoshop, which is for editing raster images, and Illustrator, which is for editing vector images. So often designs, user interface designs, are vector images. They're made up of paths rather than being made up of pixels. That allows designers to resize them. What people might not know is that the applications the user interface designer uses usually isn't the same as the standard vector illustration apps like Adobe Illustrator or Inkscape. So these standard apps are often really good for drawing. You've got lots of tools to make beautiful swirly paths and create illustrations for magazines, for banners, all types of things. However, as a user interface designer, you usually don't want swirly paths, right? Like, how many times have you used an application and seen lots of swirly lines in it? Often user interface designers, it's straight lines, it's text and maybe some example images, but that's about it. There's a different class of application, which is it's vector, just like Illustrator or Inkscape, but it's got features that are tailored for creating user interfaces. Those features usually come in the form of styles and components. So we're going to take a quick look at both of them today. I'm going to be using the Figma language for these tools. Like, different tools will call them different things. So components in Figma are called symbols in Sketch, but I think it's the same conceptual ideas. Figma is a very popular tool. You can get Figma is also a browser-based tool. There's a great free plan if you want to try it yourself, but conceptually, this is the same across most tools that user interface designers will use. So so in Figma, you have the concept of a style. I think a style is quite self-explanatory. It's a bit like a variable. So you can have a color style, which is where you define in a shared library. You know, this is the Canva blue, this is the Google blue, this is the Atlassian blue, or whatever you're designing for. And you can reuse those colors throughout. And then instead of having to remember the hex codes to use everywhere else. So that's kind of like a variable in programming sense. You know, you could chuck a variable in your SAS or in your JavaScript if you were implementing a component library. But then they also have this idea of components. So components in React terms are like they're a collection of HTML elements and some code and condition to create them. Components in a Figma term are quite similar. They're a collection of graphical elements, but obviously there's no code to create them. But what they do have, just like all buttons are kind of linked together because they're generated from the same code. In Figma, if you create a component, all instances, every time you copy, paste, or duplicate that component, they all remain linked together, unlike a simple group or a static illustration. What that means is that if you edit the original version of the component, the master, it will all of the instances of the component will update with the changes that you've made. That allows you to create that sense of consistency, but it also allows a designer some flexibility. If I'm designing a complex application, I might not want to have to design the button first, or maybe I'll design a complex application, and then my client's going to be like, I love it, but I don't like how thick the shadows are. I don't have to go back and change it individually. I want to be able to switch between designing base components, designing applications, and have everything kind of fluidly update. To give you an example of what I mean, I'm going to jump into a quick demo using Figma. So if we just jump over here. All right, here's the scenario for the demo. I'm working at a job site. It's like LinkedIn, but it's not LinkedIn. Maybe, I don't know, we'll call it Samdin. Oh, who knows? And I'm making a mobile app for my job site. So an important component for this mobile app is going to be the kind of list item that I can click on. So first, I'll just draft this in Figma. So I'll draw up a rectangle. Oh, so using the R key, it's the graphic design software. I'll use some styles on the site. So rather than risking getting the wrong shade of white, I just choose the mono white style. That's from a library that I set up before as a designer. So I can jump in there, add a shadow, add the border radius. Sweet. Now I'm going to go and I'm just going to add some text, again, using the styles. So chuck in a large title. I'll chuck in a large title job. Too large. So I'll chuck in a medium title. Sweet. So I chuck in my title. I chuck in my subtitle, job location, whatever. You're getting the idea, right? This is a component that I'd like to use throughout my application. Sweet. I'm vaguely kind of just recreating the component that I've already drafted, and I'm chucking a circle, not a comment. A circle. So I'm not a designer, so I'm not teaching you guys how to design something. Press Command G, grouped it all together. So we'll call this job. Sweet. So I've got a group. If I duplicate the group, I've got another group. I can drag one group around. I can edit the group. Like nothing to see here, right? That's exactly the same. This is not a component at this point. But if I undo all of that, delete the copy. If I first click the component button here, create component, we'll see it goes purple to denote that it is a component. And if I duplicate that, I can move the duplicated copy around. I'll set up in my mockup. Here we go. I'm going to have a mockup of a jobs page with lots of jobs. Sweet. I've set up my jobs page, put the components in there. Now, if I go and then realize, oh shit, the logo circle here, it's squashed, it's the wrong size. If I edit in the original component, we see that it's now updating every instance of the component. So that's what I was talking about when I was saying they're linked, right? I can move it around in the original component on the left. and then all of the instances on the right update. That's really useful. Another really cool thing about components is they do allow some level of flexibility, because in this job list, I might want to demonstrate in the mockup that not all the jobs are the same. So I might want to have, this could be a job at Canva, this could be a job at, another company 2. And you see, it's let me edit, the bits of the component. But still, then if I go and I change something else to the component, so maybe I decide, actually, we need to make this stand out a bit more, it's updated the attributes that I haven't overwritten. So the job title is now red, or whatever color I want to make it, even though I can edit little bits of that. Another kind of technique they use as a designer is showing and hiding. So you see in this title, in the original, in my kind of, the component that I prepared earlier, we've got a new badge in here too. So if I create some instances of that, I can actually show and hide. I can go into the instances and I can show and hide the new badge. So I don't want the new badge on those. And that's really useful because it lets me, I can go and edit the new badge later. I can be like, oh, it should be bigger. Oh, no, whatever. But it will update all the ones that have the new badge, and it won't change the ones where I've hidden the new badge. So that is components. They let me, what has that let me do as a user interface designer? It's let me change things afterwards, after I've started using something, which gives me more freedom in my design process, more freedom to go backwards and forwards between big bits of the design, small bits of the design, and that lets me build my app more quickly, because I don't have to get everything right, get sign off on those components, and then we can never change them again, right? It's way more flexible, and that also lets me makes me more effective as a designer, lets me create more consistent user interfaces. Great. This also means, and I think this is where it's most useful, is that your user interface, anyone who's designing, if you're working with someone who's designing user interface for you, they're probably thinking in terms of components too. So as a designer here, you have to make a decision about, like, should the new button be its own component? Like, what's too big to be a component? Because the individual text of the job title, that's probably too small to be a component, because it's not very useful to reuse that. But what is the correct level of abstraction, for instance? Which in many senses is actually very similar to decisions that you as a developer need to make when you're making a component library. You need to decide what is a component versus what's just some user interface that doesn't go in the library, that's not special enough to be reused in multiple places, that you're just going to copy paste if you need to. Yeah, so I suppose the moral of this story is your designers are going through similar things, so you can look towards what they've done to get inspiration about how to use it. And then, just to give an example, I want to share an example of one of the component libraries that's built into Figma. So here we go. We've got this beautiful component library here as examples of what components you might want to include. You see we've got, we've got different inputs, different buttons, different check marks, different, content. And this is really helpful, because that means then if I want to go and make a new design for something, it's very simple to, just boom, drag and drop in the search, drag and drop in this thing, very simple, makes my life as a designer easier. And thinking in the same way that I just want to drag and drop components allows us to create great component libraries and make our lives as front-enders easier. Sweet. So I think that's enough of viewing it from the designer's perspective. What do we do now that we know we have some components, we know we want to reuse them? How do we do that as a front-ender? Well, I think there's two big ways we can implement a component library. There's broadly two strategies. The first one is a CSS-based strategy, and the second one is a React or using the framework that you're currently using strategy. So in a CSS strategy, an example of that might be Bootstrap or Materialize.io. That would be a like shared CSS file or a library of CSS files that provide class names that we can use to create a component. So that we, it'll implement a .button class, a .alert class, a .slider, whatever. A React or framework one, it's going to give us React components that we can import for each UI component. Let's look at some pros and cons of each approach. So a vanilla component library, it's super easy to use, very, very simple. So here's an example of Bootstrap. That's really popular vanilla component library. We see I've got a div. I've had to add some, add the classes. So it's an alert, it's a primary alert. Add the text, it's just normal HTML. If I'm adding subcomponents, I have to make sure to add the appropriate classes there. Also, if I want to do non-CSS related things, so being more accessible by using a role property, I have to remember to do that because it's a CSS file. It can't add ARIA properties, it can't add role properties, it can't help me with accessibility. So you can only help so much. So that is one of the disadvantages. So just going through quickly, with a CSS, we're using class names. It's often using a preprocessor such as SAS, SCSS, SASS, or less to generate the CSS styles. And the pro of this is that it's really easy to use and you can use it across non-React pages. So if you have a marketing page for your application, it's just like static HTML, easy. You can just import the same CSS file. You can be consistent. Big cons of this. One, not everything can be implemented in pure CSS. For instance, if you want like a menu that pops up when you click down, there are some crazy radio button hacks, but like generally you're not going to be implementing that in CSS. You're going to need some JavaScript. Often these libraries do provide some JavaScript that you can use. So there's like a bootstrap.js file, and you add and it reads, scours the DOM to find elements with a certain class and add the functionality to them. That can be really there's the potential that could conflict with the mutations to the DOM that React is making because it's not all going through React. But also it adds extra complexity because now you have your React editing the DOM and you also have Bootstrap editing the DOM. So that is a real downside, the added complexity. Second is the lack of any sort of form of kind of type safety or even throwing errors when you've made a mistake. I can make a typo and alert, and the only way I would be able to notice that is visually. It wouldn't throw an error or something. And if I was using TypeScript, I wouldn't be able to get type errors from that, which we don't want errors in our program, that's for sure. The third one is that it's bad for accessibility, as we're talking about. If you want to add extra attributes to elements, such as for accessibility or for functionality, as we talked about initially, you have to add them manually. But fourth, and I think this is really important, is that there's poor encapsulation. I can't define an API that lets people edit the styles very easily. They can just add more CSS, kind of hook in. That makes it really hard for me to update my component library because every CSS is inherently global, as Tom talked about in his CSS in JS talk. And since you can just add more CSS to override things, it can become a mess quite quickly. Obviously, I wouldn't present two types of things and one with so many cons, but didn't have a solution. So another way you can implement a component library, and this is definitely the way we'll be looking at today, is in React. So that is every component, such as a button, an alert, whatever. It's just a React class. And you just import it from, you have a shared React file and use imports. Pretty standard stuff. This is great because you can define the API so going through the problems that we had with the last one, you can define exactly the API for customizing things. You don't have to let people add extra class names to your component. You can just say, the only way you can customize this component is, for instance, passing a severity prop to the component of an alert here. This example is from Material UI. So yeah, that would be, you can define exactly the API you want to overwrite things, and that can make it easier to use, but it can also make it easier for you to upgrade things later. Each component defines their API, which makes it more type safe. Each component always has a DOM node because each is like a React element almost always returns a DOM node. So that makes it more encapsulated. Yeah, and you can use any method that you want for styling the components. You can use style components, you can use CSS and JS, or you can just use plain old CSS files. It's pretty cool. So that is, I suppose that is one of the reasons that people often opt to create component libraries in React by exporting files rather than having a shared CSS file. One thing that you will note when looking at open source component libraries, and I implore you to do that, go and have a look at Material UI for React or Bootstrap, that's a CSS one. When you're looking at component libraries, they have great demonstration pages. So I'll often have examples of like, here's what an alert looks like that's red, here's what a warning alert, and every example of a component basically is rendered there. This is really good as a consumer of the component because you can see, hey, this is what components people have built. But it's also really good as a developer of a component library because you can quickly see here is every version of this component. When you make a change, you see how it updates every state. That gives you a lot of confidence when you're making changes, and having confidence, preventing errors. I mean, that's what you want. You don't want to be introducing bugs. And when you can see everything, all the different states of a button, one with the icon on the left, one with the icon on the right, you can make changes with confidence. And often, so as the third part of today's talk, we're going to have a look at a way that we can create amazing kind of demo pages like this that can let us make changes with confidence and also develop things faster. So if I'm developing a button in an application, I might have to wait until I've finished, developing enough of the other bits of the application, and until I have the spot where I want to put the button. On the other hand, if I have a cool demo page like this, I don't need to wait. I can just start developing all the buttons and stuff now, and then I can go and use them later as the app gets more fleshed out. This is really important in larger applications. Think if you're developing a date picker, but your date, the only time you pick a date is like 3 menus deep in the setup screen. Every time you reload the page to I need to make a change to the date picker, you reload the page to view the new version. If the only way you can access that is through the app, that means you have to navigate 3 menus every time. And that's a terrible developer experience. You're not going to be productive if you can't see your changes quickly. So that's the third reason why having a great demo page for all your components is really helpful. It lets you develop things in isolation rather than having to develop things inside the main app. So what's the way that we go about doing this? Well, we use a storybook page. It has all of the advantages that we talked about. We can build the components before the app they belong in. We can see all the states of components next to each other, and we can reload and preview them without having to navigate to the rest of the app. So the way the storybook works is that it is a separate entry point to your application. The storybook or the harness page, storybook is a common name, harness pages are another name. So you have your code, single code base, all your files, all the components defined in there. Then if we go at the top, we have our normal entry point. So that might be, we run yarn run start, yarn run build, whatever. And that builds your app, like for instance, Canva, great app. Then we have a different entry point. So it's using the same code, but instead we use yarn run storybook, and it builds a different set of files. So instead, it won't use, it won't build all the normal files, it'll build different files. So it's building basically a different app, and it builds your component library, and then you can see the demo page, and you can see all the components in one spot and develop more quickly. Obviously, you ship the normal entry point to users. That's what, if you go to canva.com, you see the Canva application. And you don't ship your storybook or harness page to users. You just keep that in your code base, and it's just for development and internal usages. So, you don't go to canva.com and see a page that has all of our different buttons on it. That's a company secret. So I'm going to jump into a quick demo. I prepared an app earlier that uses a Create React app, and it has a simple alert component. I'm going to demonstrate how we could set up a storybook inside Create React app, and I'm going to demonstrate creating a story for that alert, and I'll show you what that would look like and how it would help me developing in the future. So sweet. Let's jump into that. So sweet. As we see here, I have a Create React app. If I yarn run start, it's going to start my normal app, and as you see, this is my normal application, some application, whatever I'll zoom in. I can't see the component I'm developing because we'll pretend that it's like 3 menus deep inside my application, but in reality, I just haven't written the application. So, which are 2 valid reasons to want to have a storybook. So here I have an alert component. Hopefully this far in the course, none of this is new. We have, it takes a children parameter, a children prop, for the content, and it takes a mode prop, which will define both the styling through the class name here, and it'll also, we've got a little switch on the mode to add an icon, which is pretty cool. Yeah. So that's great. What we're going to do is we're going to use Storybook. There is a page of documentation on Storybook. I've included a link in the presentation, which I'll share around afterwards. So we're just following the documentation and using npx Storybook init. So npx is just like, it's a special npm command that downloads a package and runs it. So this is downloading Storybook, running it, and it's running in it. So it's gonna scan my current configuration of my build. So I'm just using Create React App, very standard, and it will install Storybook. Sweet. So now that we've got Storybook set up, we're just going to yarn run Storybook. Although, yeah, we're going to yarn run Storybook, and just like yarn run start in Create React App runs a dev server, this is just going to start a quick dev server. We'll also notice if we have a new terminal, we just go to our project directory. If we list SLC, Storybook has added a folder called Stories with some auto-generated documentation content. We don't need that for today, but if you're using it yourself, have a quick look, check out the documentation. I'll just quickly remove that. Sweet. So in here, we're going to create a new file for our story. We're going to create alert.stories.js. So that is, so we've got alert.js and we've got alert.stories.js. I think that's quite self-explanatory. We'll just import, React alert here, because that's what we want to display the story of. So again, we're reusing the code from the main application, even though this is not going to be, the story itself isn't going to be included in the main application. We have to export default of the title of the story. So this is alert, that's the title for all the stories. And that's just read the documentation, very simple Storybook stuff. And then we're going to export const, and this will be the name of the individual story. So I want to first do a story about the error alert. So I'll export const error. And we're just going to export the component that we want to use. So that, in this case, that's alert. Then we're going to set error.args equals, let me check that. Error.args, I'm going to set that to the arguments of the arguments that we want to use for our story. So in this case, that's going to be our mode. You know, we remember back to what error took. It took a children and a mode. So we're just going to set the mode to error, because that's what our error alert is going to look like. I'm going to set the children to some error, because that's what this story will display. Sweet. So if we save that, great. So this is loaded up Storybook, and we see right here, boom, we have the alert component. I'm not a designer, it doesn't look great, but it is an error alert. We obviously have the controls here where we can change the properties we sent it. So we can say, yay, wow, this is a Storybook. So this is great. This means that as someone developing a component, obviously an alert component, very simple component, but if it's a more complex component, a date picker, an alert with like 3 billion variants, very easy to test it, because we can just control it here without having to go navigate through the main application. So I'll chuck in a few more examples, right? We can chuck in a warning, another warning here, and set the warning prop, and obviously some warning. Yeah, and then boom. No. Yeah, so we set what we have to do here is we want to obviously because we're assigning something, but that's just renaming. It's not creating a copy. So when we set the args, it's setting on both of them because it's the same variable. So Storybook has this pattern where you go to bind and then an empty array and empty object. Sorry. And what that does is that creates a copy of the function. So the same code, but it's a different copy. And that means that when we assign to it, our warning and error stories will now be different. Epic. So this is great. This means that when I want to make a change, you know, for instance, I'm going to change, maybe I've decided we don't want the icons anymore. Boom, I remove the icons. I can very quickly go back to Storybook and see in content, see examples of this with all the different versions of my component. Awesome. So that was our demo using Storybook. I just want to highlight one cool extension of Storybook is that Storybooks can be used for visual regression. So if I wanted to go and check, and obviously the alert is a very simple example, but for more complex things, such as, you know, the landing page here, which here's an example of a visual regression test. In the real world, we have a landing page here, and we can see our visual regression test basically will take a screenshot of each storybook item whenever I make a change. So when, just like running tests, you might have it on a commit, you might have it on pull request, or it might be when you run it locally. So our visual regression test suite, it'll go through, it'll take a screenshot of like all of your storybooks, and it'll diff them to the last version of the screenshot. And that's really good for detecting unintended changes, or you can run it across multiple browsers, and you can see when something looks different when it really shouldn't. So that's another great reason that you would want to create a storybook or harness page. In summary today, we looked at UI component libraries. We looked at Figma, how Figma has great, and other user interface design software. It's got great tooling to support you creating user interface component libraries. Second, we looked at ways you would implement it. We looked at a CSS-based approach or a React-based approach. Both of them have their pros and cons, but you'll often want to create React components instead. And then thirdly, we looked at Storybook as a way to create a great demo page so you can develop a component library without having to develop the whole app around it. And ultimately, that fluidity lets you be more effective and get more stuff done quickly. Awesome. See you next time.